Now we will start with integration. See, this is the chapter where it is a summation. Integration means summation. Differentiation means disintegration. Here, integration means summation. The first letter S of the summation is elongated and written as the symbol of integration. That is, symbol of integration is what we have shown here. It is elongation of that summation word S, the letter S. See, in case of integration, there we have to observe three properties. Maximum it is 4 properties, but 3 properties are very important. Of course, you can take it 4 properties here. See, integration of f of x with respect to x is written as symbol integral f of x dx, and differentiation of this integration of f of x dx is f of x only. That is, the function itself it gives. Or you can write like this: integral f dash x of dx is equal to f of x plus c, where c is an arbitrary constant. We have to write always that c, it should accompany with, the answer should accompany with c, that is arbitrary constant. Second property, same, differential coefficient of f of integral f of x dx is equal to differential coefficient of integral g of x dx. If they are both equal, both the integral process are equal, then the function f of x is equal to function g of x. Similarly, next third problem, here integration of summation of two integration functions. Integral of summation of two functions with respect to dx is given as, individually you have to write integral f of x dx plus integral g of x dx. That means say you have to separately write f of x dx, g of x dx. Now, fourth property, integral a into f of x dx is equal to, you take out a outside because a is a constant. You cannot integrate a, we are differentiating, integrating, multiplying constant. This is a multiplying constant. So integral a into f of x dx is equal to a integral f of x dx. We are taking that multiplying constant outside. Similarly, another one property we will add now, that is very important property. Integral k into dx. Integral k into dx is nothing but kx plus c, where k is the multiplying constant. You can see here, it comes along with the function. So k into dx, so the integration of constant is always k into x plus c. This is also one of the important property. You can take all the 5 properties. Now we have seen what is integration, what are the properties of integration. Now, methods of integration. See, there are number of methods are there. Out of this, we have selected 4 methods. This is integration by substitution, which is one of the fundamental method of doing integration. This is one of the fundamental method of doing integration. Next, integration by partial fractions. Third one, integration by parts. Now, integration of special functions. Here, one by one, I will explain you. Integration by substitutions. There are number of methods are there here, out of which I have selected only 5 methods, and there are a lot of other methods. If you know these fundamental methods, you can do other methods also very easily. So that is how we have selected this integral f dash x by f of x dx. See, this f dash x is a differentiation of fx. Suppose, for example, I will explain you. For example, I will explain you what is f dash x. Say, for example, integral x dx by, say x square plus 1, x dx by x square plus 1. If you put x square plus 1 is equal to t, what is the differentiation of x square? It is 2x dx. Are we not getting f dash x dx? That this becomes f dash x and this becomes f of x. So that is how this method is explained. Later on we can apply the formula and get the answer very easily. Here also same thing. It is multiplication, x into x square plus 1 dx. Here it is a multiplication. Here it is formula method we are applying here. 1 plus f of x whole square, 1 plus t square, 1 over 1 plus t square. There are a lot of methods and formulas which we are going to do. See, now at least what is the method we are applying here. That is all. Secondly, integration by partial fractions. See, partial fractions, for example, I will tell you, we are doing this dx by, say example, x plus 1 into x plus 2. How to differentiate, integrate this? For this, what we do, we write like this, dx is equal to, it is 1 is equal to a by, we will split this fraction, plus b by x plus 2. See, that is why it is called as integration by partial fractions. We have split that fraction into two fractions and then proceed with the problems. We are going to do those problems. Now, integration by parts. Here, there is one standard formula for parts. uv dash into dx is equal to uv minus integral vu dash dx. For example, here, integral x sin x dx. Now we consider this as u and this as v dash into dx is equal to uv minus vu dash, where u dash is the differentiation of u and v is the integral of v dash. So that is the method what we have followed here. So those are all very important problem formulas which we are going to do. Now another special formulas are here. We have grouped it in 4th and 5th. See, these are all special formulas which we are going to do in the coming classes. So this is the gist of the methods of integration. Now we have already seen in integration the properties of integration and methods of integration. See, for methods of integration, we have to solve the problem by using different methods. Suppose if you want to solve the problem, we need these formulas. These are the list of formulas which are given here. See, it is called a power formula. We call it as power formula. Integral x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus c. And integral dx is x plus c. That is, the integration of dx, when added together, it will give you x. So that is the illustration we are given here. And integration of trigonometrical ratios here, cos x, sin x, secant square x, cosecant square x, different formulas we have given here. So the usage of these formulas, where exactly it is being used, we are going to see in the coming problems. So this helps us in solving the problems, these list of formulas. Okay, we shall see this problem, integral 1 over x square plus 5 into dx. For this solution is integral 1 over x whole square plus root 5 whole square into dx. You can write like this. Now here, this is in the form integral 1 over x square plus a square into dx is equal to 1 by a tan inverse x by a. You can see here x whole square plus root 5s. This is A is root 5. Therefore, this answer is 1 over root 5 tan inverse x over root 5 plus c. This is the answer. Now we shall see the first problem. Integral dx by root of 25 minus x square. See, this can be written as, this is in the form actually root of a square minus x square, which is equal to sine inverse x by a plus c. Now that is the given problem. We can write like this. The given problem can be written like this: root of 5 whole square minus x whole square. Is it not in the form a square minus x square, which is equal to sine inverse x by 5 plus c. This is the answer for the first problem. Now similarly, we will see the second problem. It is altogether a different problem. Second problem is, what he says, integral dx by root of x square plus 4. This is in the form actually dx by root of x square plus a square, which is equal to log of x plus root of x square plus a square into dx. Now this I am going to write in this fashion. You can see here, dx by root of x whole square plus 2 whole square. Here instead of a we have 2 here. This is equal to log of x plus root of x square plus 4. I'm sorry, here we need not put d plus. So this is the answer for the second problem. Now similarly, we can see the third problem. Integral dx by x square minus 25. See, this is in the form dx over x square minus a square, which is equal to 1 over 2a log of x minus a by x plus a plus c. Now you can write here in this fashion, dx over x whole square minus 5 whole square. Is it not in the form x square minus a square, which is equal to a is equal to here 2 into 5 log of x minus 5 divided by x plus 5 plus c. Our answer is 1 over 10 log of x minus 5 divided by x plus 5 plus c. This is the answer for the third problem. Now similarly, here we can see fourth problem. We will write like this: integral dx by 9 minus 4x square. So we have to convert this to the standard form. Standard form is like this: dx by 4 into 9 by 4 minus x square. Now I am going to take common 1 by 4, integral dx by, this we we can write it as 3 by 2 whole square minus x square. See, the standard form is integral dx over x square, a square minus x square is equal to 1 over 2a log of a plus x by a minus x plus c. This is the formula we use. So here 1 over 2 into a is how much? 3 by 2. I have not taken here 1 by 4 here, it is outside here. We have to take 1 by 4 log of a plus x. A is how much? 3 by 2 plus x. You will write like this. Divided by 3 by 2 minus x plus c. You can see this and this get cancelled. We get 1 over 12, 4 3s are 12, log of 3 plus 2x by 3 minus 2x plus c. This is the answer for this problem. Now we will see different problems. Integral x square minus 3x plus 1 divided by root x into dx. See here, we are going to split this x square by x to the power of root x can be written as x to the power of half minus 3 into x by x to the power of half plus 1 over x to the power of half into dx. We have written like this. Now, integral x to the power of 2 minus half, this I am doing like this, minus 3 into x 1 minus half plus x to the power of minus half into dx. Now we can see here x to the power of 3 by 2, x to the power of 3 by 2 minus 3 into x to the power of half plus x to the power of minus half into dx. Now integral x to the power of 3 by 2 dx minus 3 into x to the power of half into dx plus x to the power of minus half into dx. Individually we have done. We are applying now the power formula. X to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 3 into x to the power of half plus 1 divided by half plus 1 plus x to the power of minus half plus 1 divided by minus half plus 1. We have applied power formula. X to the power of 5 by 2 divided by 2 by 5. It goes to the top. Minus 3x to the power of 3 by 2 into 2 by 3 goes to the top plus x to the power of half into 2 by 1. 1 minus half is half. Therefore, this is equal to 2x to the power of 5 by 2 divided by 5 minus, see this 3 and this 3 get cancelled, minus 2x to the power of 3 by 2 plus 2x to the power of half plus c. This is the answer for this problem. Next, we shall go to 7th problem. See the 7th problem, sin x plus cos x by cos x into dx. This also we are going to split like this. Integral sin x by cos x plus cos x by cos x into dx. That is tan x dx plus 1 into dx. Now tan x dx, see here it is, formula is log secant x for tan x dx plus x. Therefore the answer is x plus log secant x plus c is the answer. Okay. See. Now we will see next problem. Integral cos square x by 1 minus sin x dx. See, we know that cos square theta is equal to 1 minus sin square theta. Now I will replace like this: 1 minus sin square x divided by 1 minus sin x dx. Now this is in the form 1 whole square minus sin x whole square divided by 1 minus sin x into dx. 1 minus sin square x by 1 whole square minus sin x whole square divided by 1 minus sin x into dx. This is a square minus b square. A plus b into a minus b. We will write like this: 1 minus sin x a minus b into a plus b, 1 plus sin x divided by 1 minus sin x into dx. This and this get cancelled. What do you get here? Integral 1 plus sin x into dx, which is equal to 1 into dx plus integral sin x into dx. This is equal to x minus cos x plus c is the answer. So this is the 8th problem. Now we will go to 9th problem also. Very similar to this problem. Here we have in 9th problem, in the 8th problem we had cos square x. Here we have sin square x. That is the only difference. Now we will take integral sin square x by 1 plus cos x dx. Now here also we know that sin square theta is equal to 1 minus cos square theta, or we will write like this: 1 minus cos square x divided by 1 plus cos x dx. 1 plus cos x dx. Now this we can write 1 whole square minus cos x whole square divided by 1 plus cos x into dx. Here you can see this is a square minus b square, a plus b into a minus b. So 1 minus cos x into 1 plus cos x divided by 1 plus cos x into dx. This 1 plus cos x, 1 plus cos cancel. 1 minus cos x into dx. Now this you split. 1 into dx minus cos x into dx. Or this is nothing but x minus sin x plus c. This is the answer for the problem. Okay, now see, integral root of 1 plus sine 2x into dx. Integral sine 2x dx. Basically we should know one formula. Sine square theta plus cos square theta is equal to 1. This is one formula you should know before solving this problem. Now sine 2 theta is equal to 2 sine theta cos theta. This is another formula you should know. Now applying this, root of 1 is what? Sine square x plus cos square x plus what is sine 2x? It is 2 sine x cos x. Will you agree? This formula, these two formulas we have adopted here. We have adopted sine square theta plus cos square theta is equal to 1 plus sine 2 theta is equal to 2 sine theta cos theta. Now into dx. Now this is equal to, is it not in the form a square plus b square plus 2ab? What is that? A square plus b square plus 2ab? Is it not equal to sine? Is it not equal to a plus b whole square? What is a here? Sine x plus what is b? Cos x whole square into dx. We have written. Now this square and root get cancelled. So what do we get here? Sin x plus cos x into dx. Or split this, sin x dx plus integral cos x dx. Just split. So sin x is cos x minus cos x. Integration of sin x is minus cos x plus integration of cos x is sin x. Or answer is sin x minus cos x plus c is the answer. Next we shall go to that formula problem. It is 11th problem. You will see what is 11th problem. It is integral root of 1 plus cos 2x dx. See, this is the problem. Now for this we have one more formula here. I am going to write that. We know that 1 plus cos 2 theta is equal to 2 cos square theta. See, this is the actual formula. 1 plus cos 2 theta is equal to 2 cos square theta. Now I will write like this. Integral, what is 1 plus cos 2x? Is it not equal to 2 cos square x under root into dx? Root of 1 plus cos 2x is 1 plus cos 2 theta is equal to 2 cos square theta under root 2 cos square x dx. Now I will take out root 2 common. Integral under root cos square x dx. Now this root and square root cancel. Square and root cancel. Therefore root 2 integral cos x dx. Now root 2, what is integral cos x dx? It is sin x plus c. So this is the answer for that. Now we will see 12th problem. Root of 1 plus cos 2x by 1 minus cos 2x dx. This is another important problem. You please bear it in mind. This problem is very important. See, we know that already 1 plus cos 2 theta is equal to what? 2 cos square theta. I told you, na? 1 minus cos 2 theta is 2 sin square theta here. Therefore, we will write like this: 2 cos square x minus 2 sin square x into dx. Now this and this get cancelled. Now integral root of cos x by sin x whole square into dx. This square and root get cancelled. We get integral cot x dx. Integral cot x dx is nothing but log sin x plus c. This is the answer. Log sin x. Next, we shall go to 13th problem. What is that? We will see. Integral cos 2x by sin square x cos square x dx. Now we know that cos 2 theta is equal to cos square theta minus sin square theta. This is one formula we have. Therefore, I will write here, it is cos square x minus sin square x divided by sin square x cos square x into dx. See, I am going to split this like this: cos square x by sin square x cos square x minus sin square x by sin square x cos square x into dx. I have written like this. Now this cos square x cancel. Here sin square x cancel. 1 over sin square x is what? It is cosecant square x dx. I am splitting separately, writing separately. 1 over cos square x is secant square x dx. Now integral cosecant square theta d theta is minus cot x. Now integral secant square theta is tan x. So plus c. So this is equal to, answer is minus of tan x plus cot x plus c. This is the answer. Now we shall see this problem: 1 over 1 minus sin x. Rationalizing the denominator. I think rationalizing the denominator. See here, 1 over 1 minus sin x into 1 plus sin x by 1 plus sin x into dx. Now this is equal to 1 plus sin x divided by 1 plus 1 minus sin square x into dx, because a minus b, a plus b is a square minus b square. 1 plus sin x is on top, denominator 1 minus sin square x. But 1 minus sin square x is nothing but cos square x. So I will write like this: 1 plus sin x by cos square x dx. Now we will separate this. Integral 1 over cos square x dx plus integral sin x by cos square x into dx. I am separating this 1 over cos square x separate plus sin x by cos square dx is separate. Now it is secant square x dx plus integral. See, I am going to split like this, sin x by cos x into 1 over cos x. Sin x by cos x is tan x. 1 by cos x is secant x dx. Now this is nothing but tan x plus secant x plus c. This is the answer. Now we will go to the other problem. Here I am going to substitute for, I will write the problem first, better, 1 over sin square x cos square x dx. I will do it like this. Instead of 1, I will write sin square x. Instead of 1, I will write sin square x plus cos square x. What is sin square theta plus cos square theta? It is equal to 1. Therefore, I have replaced 1 by sin square x plus cos square x divided by sin square x cos square x dx. Now, integral, we will separate now. Same what we did in the previous problem. Sin square x by sin square x cos square x plus cos square x by sin square x cos square x dx. Now you can see here, this goes and this goes. So 1 over cos square x is secant square x dx plus, we have split like this, 1 over sin square x is cosecant square x dx. Now secant square x dx is tan x minus cosecant square x dx is cot x. So this plus c is the answer for this problem. Now we will see this problem. 1 plus cos x by 1 minus sin x dx. Now in the first instance itself we will split like this. 1 over 1 minus sin x into dx. 1 over 1 minus sin x into dx plus integral cos x by 1 minus sin x into dx. Have you understood here? We have split this problem 1 over 1 minus sin x plus cos x over 1 minus sin x. Now here we are going to rationalize this. 1 over 1 minus sin x into 1 plus sin x by 1 plus sin x I am going to do into dx plus here 1 minus sin x, here also same thing, 1 plus cos x, I am sorry, 1 plus sin x by 1 plus sin x into dx. Now here we will write like this, 1 plus sin x by 1 minus sin x, 1 plus sin x, a minus b, a plus b, a square minus b square, that is 1 minus sin square x into dx plus integral cos x into 1 plus sin x by 1 minus sin x, 1 plus sin x, 1 minus sin square x into dx. This is also of same thing. That is all. Now we will do like this. Integral 1 plus sin x over cos square x dx plus integral cos x into 1 plus sin x by cos square x into Have you understood here? This is, we have 1 minus sin square x cos square x. 1 minus sin square x cos square x. Now this is 1 over cos square x dx plus integral sin x by cos square x dx. I am splitting here, plus, see this and this goes. So plus integral 1 over cos x dx plus integral sin x by cos x dx. Now this is integral secant square x dx plus integral secant x tan x dx plus secant x dx plus tan x dx. See? Integral secant square x dx is tan x plus integral secant x tan x dx is secant x plus integral secant x dx is log of secant x plus tan x. This is the formula for secant x plus integral, it is log secant x plus c. So this is the answer for. Now we will go to the other problem here. Sin x plus, we know sin 2x, I have already told you, it is 2 sin x cos x. Sin x plus sin 2x is 2 sin x cos x divided by sin x dx. Do you agree? Now, what is common here? Sin x. I will take sin x common. If I take sin x common here, 1 plus 2 cos x divided by sin x into dx. Now, this sin x and this sin x get cancelled. We will split now. Integral 1 into dx plus integral 2 cos x dx. So integral 1 into dx is x plus integral cos x dx is sin x plus c. This is the answer for that.